In this video, we're going to take a look at the Model Mania Design Challenge from 2009. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are presented with a drawing similar to this and are tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're finished creating that part, they're given a second drawing with either a series of changes or additional tasks to perform. In this case, those Phase 2 tasks are going to be to perform simulation. Keep in mind, attendees never know what the second phase is going to entail. So let's go ahead and dive right in and look at creating this part. It's not all that complicated, but we're going to use a lot of things that we've looked at in previous videos in this series, starting with drawing a lot of the sketch geometry in a single sketch to make things easier later down the road. So that's where we're going to go ahead and start. I'm going to start by sketching on the top plane, and you'll notice that I'm going to capture the majority of this part's features inside of this individual sketch. So in this example, I'm creating all four circles here, and let's go ahead and locate this vertically to that one and set the distance between these two as 125 millimeters. We'll then go ahead and also draw the tangent lines between these. Remember, drawing straight off from by clicking and dragging off from a circle in a tangent motion will capture those tangent relationships much easier. Once this is done, we can go about using this geometry. Now, one of the things that I'm going to do is I'm going to show a way not to do this to avoid an issue later. One of the default things you may want to do is choose this entire region to basically capture two features at once. In a lot of cases, that works just fine. Let's go ahead and do this on the other side by re-clicking on that sketch and reusing it. And again, on this case, we're going to go ahead and we're going to reuse this. We're going to say 20 millimeters, and we're going to get the elevation difference here, we're going to go ahead and use the offset option to drop this down 30 millimeters. Now what we want to do is we want to create that jog feature that appears between these two. So I'm going to go ahead over to my right plane to do this, and I'm going to start by drawing this line straight out, and then there's another one over here, it's 40 millimeters, and then I'm just going to click and drag this and snap that to the midpoint over there. There's also a few fillets here which we'll go ahead and add right now while we're in this sketch. And then we're going to go ahead and choose to extrude this. Now, an easy way to do this is just to right click and say through all in both directions. So I'm going to set both directions to through all. We'll set the proper thickness for the thin feature and the proper orientation. And now when we press OK, look what's happened. It's actually included this material on the inside of these. So we're going to end up having to go back and remove it after the fact anyway. So we really didn't save any time by doing this. The better way of doing this is when we created these features is when you chose the sketch regions, instead of choosing that region, just choose the entire circle. Now keep in mind when we do this for the second circle, because we reference the bottom edge of this, we are going to have one of our sketch relationships go dangling. But that's okay. This is easy enough to fix. You'll notice that the endpoint of this is brown and that the midpoint relationship is missing. Sketch relationships in SOLIDWORKS can be reapplied by simply dragging and dropping those to a new entity. And notice by doing that the endpoint is now black, and it solved that. So now all we need to do is get the proper shape this time. For that, we're going to go back to that original sketch that we created, and we're going to choose to do a cut. Now, this is where things get interesting. We want to cut away all the material to the outside in both of these holes at once. Well, I can select the holes, but how do we cut the material to the outside? Well, I'm going to do this a little counterintuitively. I'm actually going to choose everything we want to keep, and I'm going to choose the option flip side to cut. This actually performs a bit of a Boolean operation where it's going to keep everything I've selected and cut away everything else. Now notice when I do that, the part looks great. Well, there is a bit of a problem. If you look down here, you'll see that there's this extra ledge that's been created. If we go to our top view, we can see why that's happened. Before we created this cut, notice that this material didn't extend past this tangency point. So we're going to want that additional material there, or we will run into problems later on when we go to create our fillets and create our draft. An easy way to solve this is to go back into this sketch and just create a little bit of additional material. And because we're going to use the flip side to cut option inside of SOLIDWORKS, we can go ahead and just extend that out. We could literally extend that as far as we wanted, and the flip side to cut is going to take care of that. Notice that that lip is gone in this case. One of the other things that we want to create is we want to go ahead and create this rib feature, which I'm also going to go ahead and create on the right plane. Now for this, you could do this several different ways, but what I'm going to go ahead and do is I'm going to draw the two lines that come off from the top of these surfaces. Now I could create an additional line, make it parallel and dimension it there, but we could, while we're here, just go ahead and simply perform an offset relationship. Now that leaves all of this geometry to be cleaned up. Well, we actually do need to create some fillets here, and we can do this all within one command. Notice that the fillet tool allows us to actually extend that geometry to get exactly what we're looking for in this case, and then we can go ahead and use that as a rib feature. All we need to do is set the thickness and ensure that the material is going the right way, and notice when we press OK, SOLIDWORKS just fills in the geometry where that rib needs to be. There's also a tapped hole that needs to go on this round face. Now this oftentimes presents a challenge for new users because they're used to creating holes on planar surfaces. Well, the hole wizard's quite versatile. First thing we need to do is we need to choose that we want to create a tapped hole, and you'll notice I've set this here and here, and then we choose the appropriate size, M10 by 1.25, and we're going to set the end condition for both the drill hole and the threads to be up to next. For the position, just like when selecting a planar face, you'll notice this button that says 3D Sketch. If you choose a face that's not planar, SOLIDWORKS is automatically going to put you into a 3D sketch mode here. And you'll notice that I dropped this point on this face, and you can see that it's got a relationship called on surface. When you're working in a 3D sketch environment, you have a few more sketch relationships available to you. For example, I can just ensure that that point always falls on that plane, that right plane. So that way it always intersects the middle of the part. Additionally, when we dimension, notice that when you dimension to a circle in a 3D sketch, you actually dimension to the center of that circle. So you want to be careful how you go about dimensioning things. In this case, we're going to dimension to this bottom face instead to this point, and notice that that gives us the appropriate 20 millimeters off from that bottom face in this case. Now when I press OK, SOLIDWORKS creates the tapped hole. The last thing we want to do is we want to create the draft and the fillets on this part. So I'm going to start with draft, and we're not going to use neutral plane. We're going to use parting line, and we're going to set the draft angle to 4 degrees. For the pull direction, we will choose the top plane. And what we basically want to do is we want to choose all these bottom edges of the part. Well, a really easy way to do this when you have tangent edges to one another is, like a fillet, you can choose to select tangency. And notice it'll automatically grab all of those. Let's do this up here on the top as well. We're going to right click, choose select tangency, and I'll do this on this other edge as well. And then all we need to do is right click to confirm, and we've created the draft on all of those faces. The last thing we need to do is go ahead and create a series of 2 millimeter fillets. If you've watched the previous videos, you already know why I select faces. It's because it automatically chooses all of the adjacent edges, and then with the tangent propagation option, automatically propagates to all those other edges. This means that I only really needed to select 8 different faces, and I got all these edges in the process. So I'm going to go ahead and press OK. There's a few other things we need to do. I am going to go ahead and change the color of these fillets for clarity, just so that we can see that we've got all the right fillets here. But you'll notice on the drawing it does call out a material specification. Okay, so let's go ahead and set the material for this part. To do this in SOLIDWORKS, you right click on the material node in the feature manager tree, and you can select from one of your favorite materials, but the material specified, 6061 T6SS, isn't here. So we're going to go ahead into our library. Well, 6061 is not a steel material, so let's go ahead and close this and go into our aluminum library. You can see that it's quite vast, so we'll have to scroll down a little bit, and there it is, 6061 T6. Now notice when I choose this material, it's going to do a couple things. It's going to set the appearance of the part to look like aluminum. It's also going to change the crosshatch on a drawing. If you look at the drawings, you'll notice that it has this crosshatch. But it's also capturing a bunch of physical properties of this part, including things such as the yield strength and the density. This is valuable when you want to calculate weight, but also the strength of the part. So let's go ahead and apply this material and press close. Now you'll notice that we do have the different material on here, and if we go into evaluate, we can get the appropriate mass property now and get the actual weight of this part. But let's go ahead and now that we finished phase 1, let's go ahead and look at phase 2. Phase 2 of this Model Mania Design Challenge actually is to perform a simulation on this part. So it's actually important that we just apply that material. Because in order to calculate the physical properties of a part, you need to know what it's made of. So this is actually a pretty easy simulation. You'll notice in the notes it says you can use Simulation Express or SOLIDWORKS simulation if you so desire, to analyze and determine the factor of safety and the maximum deflection of the part. So let's go ahead and walk through this. For this video, we're going to go ahead and we're going to use Simulation Express because Simulation Express comes with every version of SOLIDWORKS. You don't have to have SOLIDWORKS Premium to do Model Mania. So Simulation Express will walk us through the process where SOLIDWORKS simulation will actually, you might need to know a little bit of this information. But it's fairly straightforward. The first thing it's going to do is tell us to create a fixture. And for this, what we want to do is we want to restrain this face right here. And for that, basically what we're going to do is add a fixed restraint relationship. So we'll press OK. There's no more restraints, so let's move on to the next step. Then we need to go ahead and add a force. The force in this case is going to be added to this round face. But notice the direction. We're not applying the force outwards, we want to apply it straight down. So for this, we're going to change the option to select a direction. And in this case, we're going to go ahead and just choose a reference plane. In this case, our top plane will choose to reverse our direction. Then we need to go ahead and specify our force. If you're working in pounds, this would be 225 pounds. If you're working in newtons, it's going to be 1,000 newtons. And then we go ahead and press OK. Then again, we move on to the next step where we could specify the material if we missed this step previously, but notice because we have applied this, it's automatically captured. We'll go ahead and choose Next and choose to run the simulation. Give SOLIDWORKS a few seconds to go through this process. I think it takes about 6 or 7 seconds. And it gives us some initial results for us to determine, is this what we expected? Well, yes, it is. Let's go ahead and take a look at the actual results. When we do this, we get a factor of safety on this part of 4.03055. Now, there could be a little bit of variance in there depending on your mesh setting, something you could have tweaked, how fine you want the mesh to be. In this case, we could go in and we could look at where is the factor of safety, for instance, below 4.5. And when we do this, we see that it does fall on the rib of this part right here. But one of the key things that we're looking for is the displacement. And in this case, it's 0.00318 millimeters in this case. We're viewing this in scientific notation. So we'll have to move this 3 decimal places over. So yeah, 0.00318 millimeters is our maximum displacement in this case. So you would then jot down those results. So there you have it, the Model Mania Design Challenge from 2009. Hopefully you learned a few new tips and tricks here, and simulation is much more approachable than you thought in the past. SOLIDWORKS World is quickly approaching, and to learn more about it, either visit the link in the description below this video or in the blog post where this is hosted.